Okay, let's look at the practice Lewis structures worksheet. Group A, simple molecules. These are the types that we did in class. Let's look at silicon tetrafluoride. We have SiF4. First thing that you need to do is to look at your periodic table and determine the number of valence electrons for each atom. Silicon has 4 valence electrons. Fluorine has 7, and there are 4 of them. That will be 28 valence electrons. So 4 plus 28 means that we have 32 total valence electrons. Okay, remember, we look for what is the central atom, and we put that in the middle. Fluorine is a halogen. It does not want to be a central atom. So we go with silicon in the middle. We then put all of the other atoms around it, and we create a single bond between each of those using up 8 electrons. And that leaves us with 24. We then put these 24 electrons in pairs around the most electronegative, or the furthest to the right, and those will all go around fluorine. We've used all 24, 8, 6, 12, 18, 24. We now have 0 valence electron. If we look, we have octet fulfilled on all atoms. This is a properly drawn Lewis structure. All right, let's look, and we're going to skip group B right now. Let's look down at group C, and you'll see that we have HCN. This is an example I did in class, but this is a good example to do over. Hydrocyanic acid has 3 atoms. Determining valence electrons, hydrogen has 1, carbon has 4, nitrogen has 5, and that will be a total of 10 valence electrons. All right, we determine the central atom. We know carbon likes to be in the middle of everything. So carbon is our central atom, and hydrogen and nitrogen go on either side. They can go on the top and the bottom, doesn't matter. We create a single bond between each. That uses 4 valence electrons, which leaves us with 6. We then put these 6 in pairs around the atom that's furthest to the right. That will be nitrogen, and we end up with this situation. So now, we've used all electrons. We now look at our structure and realize that we do not have octet fulfilled on the carbon. We have octet on hydrogen because hydrogen only needs 2 associated with it. We have 8 octet around nitrogen, but we only have 4 around carbon. So what we then must do is create a double bond using one of those lone pairs from nitrogen, and now we reevaluate. We see now that carbon only has 6 electrons associated with it. We need 8, so in this case we need to make a triple bond between carbon and nitrogen with one of the lone pairs on nitrogen, and now we have octet fulfilled on every atom, and we have the properly drawn Lewis structure. I will refer back to my notes and the rules and try to practice on these.